Okay, well, one of the feedbacks from the last session was there's too many suppliers and not enough sheep plants, and here's another supplier talking to you. So apologies for that, but hopefully you'll find it interesting. So my name's Shaun Baker. I'm sales manager for WH Leary Limited. If you know WH Leary, you'll know us for gluing systems, for glue detection systems, for quality assurance solutions. But actually today I'm going to talk about something different. Actually our partner company is Robotech, based in Switzerland, and they have developed something which is pretty exciting. I hope you find it exciting. It's a solution which it's called Perfect Fold. It's specifically being developed for the corrugated converting industry. And I'm holding in my hand a box just in case no one knows what one of these looks like. One of the things, the trends in the industries, or the movements in the industries, has been the move towards higher tolerance of production of corrugated boxes, both dimensionally and in terms of the speed of the production as well. Why has that been driven? What's been driving that? And it's from a few different perspectives. One has been aesthetics. You can tell when a box isn't folded and glued correctly. Secondly, is from a functional point of view. So boxes corrugated boxes need to be more dimensionally accurate, so because of inserts into the box, because of the tolerance between the product that's being put into the box. And also, probably more important than all of that, because increasingly boxes are being automatically erected at the packing side of things. And if a box is out of tolerance, then it can cause issues at that point. So some of the things that have an impact on the box, are gap, fishtailing, and cracking. I've got a few notes about these. Maybe this is a little bit of box manufacturing 101, so apologies for those who know this industry far better than I do. So what's a gap? It's a manufacturer's gap. So when the box is folded, then there is a gap that is produced at this point. And this gap is variable. And it's variable for a reason, and it's something that traditional manufacturing can't find a solution to solve. So the reason being that of course, corrugated, because of the fluting, it's not a consistent product. It's not like carton board. It's kind of got a grain in it, I would describe it as. And when you mechanically crease the board and then try and fold it, there's a theoretical line, and if you hit it exactly between the corrugate, maybe the crease follows that line. However, if you miss that particular point and you're slightly to the left or to the right, you end up then with a crease which falls offline. Sometimes it jumps flutes as well, the creasing. People who manufacture will recognize that. And that has an impact then, ultimately, the variability of this manufacturer's gap. Another quality characteristic, and this is kind of linked to the same sort of issue, is fishtailing. And fishtailing comes from when the board is folded, not square, but it's folded with an angle. And again, that's normally characterized because the manufacturer's gap becomes small on one side and larger on the other. Another quality defect during folding is cracking of the board. We recognize when a box is in use, once it's packed, it's got 90-degree angles all round, but of course in manufacture, two of the corners are folded 180 degrees. And it's these edges which are prone to cracking and damage. So the question is there a solution? And you'll be unsurprised to hear, yes, there is. And the solution is a solution. Robotech have developed a solution which is a wettening of the crease line, and this then has the impact of ensuring that the fold carries out in the line where it needs to, and it's not dragged into the grain of the corrugate. This is what the solution looks like. It's really two-part. The equipment, which is applying the liquid, and this is an inline application process, so it's added onto, for example, a flexo folder gluer. The liquid is applied just before the folding happens, but probably the most important thing about this, or the most important aspect of this solution, is the liquid itself. People have tried this in the past. I know there'll be people out there who maybe have tried it as well. But the solution now, within a matter of seconds, goes into the structure of the corrugate and into the flute as well, and softens within. Typically, we're applying the liquid just 1 or 2 seconds prior to folding, and that is enough to make this big difference. To the right there is water. Lots of people say, well, you're just applying water. It's not water. It's a specially designed, developed liquid. So that's what it looks like mounted on a machine. You can see we're applying the liquid. We just need to apply on the two lines, which are going to be folded. This isn't instead of creasing of the box. This is as well as, although it can be instead of, because it does operate very well. But in retrofit situations, we put it in addition to the standard machine. It can be fitted, it can be retrofitted. It works at speeds of up to 350 meters per minute, so it's a very fast system. And ultimately, you're starting to see some of the benefits of this, which is you get more accurate dimensions, more repeatability, fewer changes and adjustments to the creasing tools. You can move the creasing line only by moving the liquid, and that is the proof of what it's achieving. So a mechanically creased box, you can move the creasing line, and therefore you can adjust these gaps just by moving the position of the creasing liquid. Got a little video here showing it. I'm pleased to say I've switched off the sound because that was all a bit horrible. And you can see the liquid being applied. It's slowed down here. In this case, it's been applied down this full length of the crease, and then immediately it's being folded over. And this is what it looks like once the liquid has been applied. And you can see that what it's done is it's removed the resistance of the corrugate for folding, and it's basically been dropped into position in this example. And the proof of the pudding is in the eating. So the proof of it is in the results. And these are results from customers. These are not our results. So we have installations already on machines in the UK. Some people in this room work for companies that already have this installed. Statistically, it gives much better control over the manufacturer's gap. By getting control over the manufacturer's gap, or the manufacturing gap, you get control over the dimensions of the box itself. Because it softens the through to the corrugate as well, actually into the material. It also overcomes issues of breakage of the spine, which can happen, particularly with thicker corrugate. And there's a thick bit of corrugate. So you can do multi-wall thickness as well with this solution. There's also, by applying it over just part of the length, and this is all controllable where the liquid's applied. So here it's only being applied over half of the length. Then you can also bring fish tailing into control as well. So yeah, in summary, it's a liquid application of a liquid solution, a softener on the creasing of the corrugated box, achieves higher precision of the box, control of the process. We're avoiding the cracking down the spine. And another very key point, because I've heard from manufacturers that the way they achieve more difficult, more challenging production qualities or standards is to slow down the process. But of course, that's an impact on efficiency as well. So we can still run this at full speed. Thank you very much.